Let's go ahead and look at this same problem in another way. So this is the exact same problem, the exact same work that I had up above. So this example is the same problem. We're just going to integrate it a little bit differently. And actually, I guess our approach really isn't different in terms of the beginning, but our approach will be a little bit different toward the end. So identical problem. I still have my even powers of both sine and cosine. They're even and positive. I rewrite using my half angle identities, and I go ahead and expand my first outside inside last on the second and third binomials, and I end up with the same point. Now on the last way that I solved this example, I went ahead and FOILed this out. But here I would kind of like to note that 1 minus cosine squared kind of seems a little familiar. So let's think about, in terms of a Pythagorean identity, how we could rewrite this. So I have 1 minus the cosine of 2x. I'm not going to change that right now. But what about 1 minus cosine squared? 1 minus cosine squared is sine squared of 2x. And of course we can't forget to drop or don't drop your dx. So again, this came from the fact that I know that sine squared argument plus cosine squared argument equals 1. And then of course solving for 1 minus cosine squared argument, I get sine squared argument. And this will actually make the problem a little bit shorter, it seems at first, but I also run into some troubles with expansion here as well that end up being a little bit longer. So now I distribute through the sine. Distributing through the sine, I have sine squared of 2x minus sine squared of 2x cosine of 2x dx. So it looks a little shorter right away. I don't want them to get pretty long. Let's go ahead and split this up into two separate integrals because we're going to be working with this in two different ways. Don't forget to distribute the 1/8. Don't want to make an algebra mistake there. And then I look at this first one and say, okay, I have an even positive power of sine. Well, how do we deal with that? You could rewrite it as 1 minus cosine squared, but that doesn't really solve my problem because then I'll have an even positive power of cosine. So what I need to do is I need to rewrite this using a half angle identity. So let's go ahead and look at a half angle identity. Sine squared of 2x is going to be equal to 1 minus cosine of 4x, because remember how we have to double that angle, all over 2 dx. Now here, minus 1/8, I'm going to let u equal the sine of 2x. du would be 2 cosine of 2x dx. So I have the cosine of 2x, I need the 2, so I multiply by 2 on the inside, compensate with a 1/2 on the outside, and rewriting there, oops, I don't have a 1/8, I have a 1/16, because I use that for compensation, so that becomes a 1/16, and this is going to be u squared du. Okay, going to our next step in rewriting, I end up with 1/8 integral. Actually, let's go ahead and pull that 2 out as well, and let's call this 1/16 integral of 1 dx minus 1/16 integral of the cosine of 4x dx. And then working from this next one, I have a negative 1/16. The integral of u squared is u cubed over 3, so I'm going to be multiplying that denominator by 3. And we'll have to make that substitution again. Well, here's our easy part. The integral of 1/16 dx is 1/16 x. Now this one, again, I'm going to have to use a u substitution. Let's not use u because we already have a u in the problem. Let's use a w. W is 4x. dw is 4dx. I don't have the 4, so I multiply by 4 on the inside, compensate with a 1/4 on the outside. And when I rewrite that, I get a negative. Actually, let's go ahead and leave that coefficient out front. 1/64 integral cosine of w dw. Now for this next piece, I've already integrated it, I just need to rewrite it. 16 times 3 is 48. U cubed. but u in this case was sine of 2x. So this would be sine cubed of 2x. So I'm getting closer. Let's see if we can get this simplified to match our other solution. Minus 1/64. The integral of cosine of w would be sine of w, but in this case the w was equal to 4x. The w was equal to 4x, so I make that substitution. And of course I have my minus 1/48 sine cubed of 2x. And then from here we want to find a common denominator. The least common denominator is going to be the same as it was when I worked the problem before. It'll be 192. So when we find that common denominator, we need to multiply top and bottom here by 12, top and bottom here by 3, top and bottom by 4 to get that common denominator of 192. So rewriting, I have 12x minus 3 sine of 4x minus 4 sine cubed of 2x all over 192 plus c, constant of integration. Now, hopefully this matches what we had before, so let's go up and have a look. Same problem, different approach. Okay, here's the solution for our other approach. Same problem, we just changed how we rewrote in the middle of this using a Pythagorean identity. So we did get the same solutions. So you'll notice there is quite a bit of calculus going on here, but for the most part, most of the work is algebra. Thank you.